Okay, here's another example of solving rational equations. And again, we want to find the least common denominator. And it looks like if we look at all these denominators, it's going to be, so we'll build it over here, the LCD. And it looks like we need a y minus 1 and a y plus 1 and a 3. So that's my least common denominator, so I'm going to multiply every term by y minus 1 times y plus 1 times 3. And you can see that each of these divide into the LCD. So I'll kind of rewrite this out, a little more room. Y plus 1 over y minus 1 minus y minus 1 over y plus 1 equals 8 over 3. And we'll multiply this each term, so times 3 times y minus 1 times y plus 1, 3 times y minus 1 times y plus 1, and then 3 times y minus 1 times y plus 1. And remember, y minus 1 times y plus 1 is just the same thing as y squared minus 1, because it's a sum and difference of the same number, so it's the difference of perfect squares. So that might save us a little bit of time when we're multiplying these out, especially on the right side. Okay, so the y minus 1 over y minus 1 is 1. So over here we have left 3 times y plus 1 times y plus 1. Okay, on the right, these y plus 1s become 1, so I've got 3 times minus 3 times y minus 1 times y minus 1. And that equals, and then over here, 3 over 3 is 1, excuse me. So I've got 8 times, and I'll just use the y squared minus 1. It's the same thing. Okay, now I've got to multiply these out, and I got rid of the fractions, but now I've got this pretty formidable situation over here, so we've got to multiply these out. So we've got 3 times, and if I multiply this, I'm going to have this binomial times a binomial. I use the FOIL process. I've got y squared plus 2y plus 1 minus 3 times y squared and then minus 2y plus 1. And this equals 8y squared minus 8. And if I multiply it again by 3, I've got 3y squared plus 6y plus 3, and then I multiply by negative 3, so I got negative 3y squared plus 6y, and then minus 3. And that equals 8y squared minus 8. And 3y squared minus 3y squared, that becomes 0, so that's nice. 3 minus 3 is 0, so I just have 6y plus 6y is 12y. So I got 12y on the left equals 8y squared minus 8. Okay, so I got a quadratic, so I'll subtract 12y from both sides, and I've got to set it equal to 0 and solve it. So that's what I'm going to do, subtract 12y. And I end up with 8y squared minus 12y minus 8 equals 0. So there's my quadratic, where 0 equals that. So now I got to deal with this. Now what I can do is I can divide everything by 4, and that's going to make my life a little bit easier. And I end up with this 2y squared minus 3y minus 2 equals 0. So now I've got to factor this. Now this is a general trinomial, so I can use my general trinomial method, but because this is a prime, it's a little bit easier, so I might get away with it just by kind of noodling it out. So I know the only way I can get 2y squared is 2y times y. Remember, that's still equal to 0. So now I have to kind of fiddle around with these. And the only way I can get 2 is by 1 and 2, so I just have to kind of try what's going on. So I can use a pencil here and put some numbers in. So I could try 2 over here and 1 over here and see what happens. Now, 2 times 2 is 4, and 1 times 1 is 1, so I've got 4 and 1. That's going to give me my 3. So I want to make sure I end up with a negative 3, so if I can put a little negative over here and a positive there, let's see if that works before I write it in. And this is kind of like just noodling it out. You can use that 4-term method, the grouping method by multiplying the first term times the third term and rewriting the middle term, but these are a little bit easier because we do have prime numbers here and here. So negative 4y plus 1y is negative 3y, and a positive 1 times a negative 2 is a negative 2, so that's going to work. So I'll ink them in now, so this is going to be plus 1 and minus 2. And again, always check it. 2y times y is 2y squared. Outside terms, negative 4y plus 1y is negative 3y, and negative 2. So we know if two things multiply to give 0, one or the other must be 0. So 2y plus 1 equals 0, or y minus 2 equals 0. So I put this in if I solve this, if I subtract 1 from both sides, 2y equals negative 1, y equals negative 1/2, and if I add 2, y equals 2. So I got two possibilities. Now we usually have to check these fractions, so it becomes kind of a bit of a hassle. So you really want to check your equations to make sure it works out. So if I put 2 in here, so this is the check. So 2 plus 1, so every time I see a y, I'm going to put a 2. It's just going to work. So 2 plus 1 over 2 minus 1 minus 2 minus 1 over 2 plus 1. Does that equal 8/3? Well, 2 plus 1 is 3. 3 over 1 is 3. Minus, and then if I say 2 minus 1 is 1. Over 3, and 3 is 9/3, so 9/3 does minus 1/3 is 8/3, so that's okay. That's checks. Now the hard part is we've got to put negative 1/2 in, so this is going to be a little trickier. So we got negative 1/2 plus 1 over negative 1/2 minus 1 minus negative 1/2 minus 1 over negative 1/2 plus 1. Does that equal 8/3? Well, 1 minus 1/2 is 1/2, so I got 1/2 over negative 1, and negative 1/2 is negative 3/2. Okay. Minus, and this is going to be negative 3/2 on the top. And this is going to be 1/2. Okay, so let's see what this is equal to. So this is the negative, and 1/2 over 3/2 is just going to be, we have a 2 in the bottom, so it's just going to be 1 over 3. And a negative times a negative is a positive, okay? And 3 over 1 is 3, so it looks like we have the same thing we had over here. 9/3 minus 1/3 is 8/3, so that also checks out. So we checked it out. Okay? So both answers work. So this is my solution set. So that was pretty challenging because with all the fractions and checking. Okay? So I hope that makes sense.